This is Catherine Schmer at Chattanooga State Community College. This is video 3 for the dot product section. In this video, we're going to talk about work as a concept from physics. In physics, the work done on an object by a constant force directed along the line of motion is W equals F times d, where d is the displacement of the object. Note that this only holds if the force is in the same direction as the displacement. So if the force is in a different direction, the work will be calculated using the component of the force that's in the same direction as the displacement. So for example, say you were pulling a suitcase along, but you're actually pulling a little bit up at an angle. In order to figure out the work done sliding it horizontally along the floor, we would have to figure out how much of the force was directed in the horizontal motion as opposed to the vertical motion. So here's our figure. We're moving an object from point P to point Q, and so we draw a vector D between P and Q, where P is the center of the object where it started, Q is the center of the object where it ends. So D is the length of that vector, or D is actually that vector, and the magnitude of D would be the displacement. Now we have a force that is pulling on that object in order to move it, but the force is actually pulling up from the horizontal at a little bit of an angle, and we call that angle theta. Now, using right triangle trigonometry, we can figure out the horizontal component of that, and that would be the magnitude of F times cosine of theta. So there's our force in the direction of displacement, because we're moving the object horizontally. So now the work done by a constant force, remember it's your force in the direction of displacement times the displacement. So the work done by a constant force F during a displacement d is the magnitude of F times cosine theta, which was our horizontal force, times the magnitude of d. So remember, this is actually, by definition, the dot product of F and d. So work is equivalent to force dotted with displacement as vectors. So vector force dotted with vector displacement, which is equivalent to the magnitude of force times the magnitude of displacement times cosine theta. So let's actually apply this to a problem. We want to know how much work does it take to slide a crate 20 meters along a loading dock by pulling on it with a 200 Newton force at an angle of 30 degrees from the horizontal. So first of all, I see this 20 meters. That must be the magnitude of my displacement. So I write down magnitude of displacement equals 20 meters. Now the next thing I see is 200 newtons. So the magnitude of the force is 200 newtons. The last thing I see is 30 degrees from the horizontal, so that tells me that theta equals 30 degrees. So I have all the pieces that I need. Now just a side note, the capital N is a Newton, and if you've had physics, you've probably worked with it quite a bit, but if you have not, a Newton is kilograms times meters over second squared, and that's one of our typical measurements of force, is measuring in newtons. Okay, so now I want to figure out work. We know that work is the magnitude of F times the magnitude of D times cosine theta. So I'm going to plug in the numbers that we figured out from the problem. 200 newtons times 20 meters times cosine of 30. And I know that cosine of 30 is square root of 3 over 2. So I get 2,000 times the square root of 3, and my units are joules. Now, joules are Newton meters, newtons times meters, which is what we ended up with when we calculated the work. So your work answers are always either in joules or foot-pounds in the problems that we're going to be working. And that is your lesson on work.